This is part 15 of the basic Python programming tutorial for Blender users. Okay, in the previous lesson we had looked at this fountain search function, right? So we could find specific fountains around our circles that we have in the scene, and more importantly, what we had done is we had changed this comparison to be very specific, so it was, comparing it to pi divided by 4 instead of a specific number. That way we can be more accurate. That way our fountain numbers were had more accurate representations. And so in this lesson I'll show you why that becomes important, because then we can use those numbers within our code to search more specifically for things and to do things. And not only that, we're going to, since all along we've actually had particle systems built in here from the beginning. So if I press Alt A, there's our existing particle system. In fact, oh, that just gave you a clue. That's what we're going to be doing in this lesson. So let's go see what we have. I'll go look at this full screen, and I have another routine this time called modify fountain particles. And there's two types. One's called modify all fountain particles, and the other one's modify specific fountain particles, like this. So first thing we'll do is we'll modify all the fountain particles, and we're going to do this the same way we had done before, by cycling through all the objects in the scene like this. And as I go through them, I'm deselecting all the objects just in case. And then for the current object that's within the loop, I make sure I set it to true. So basically the selection becomes true. Otherwise, if you don't do it, it can pick up on the object that you last right-clicked in your scene, and that can be your selected object. So I don't want that. I want to make sure it's always selected. And then being selected, then I'm going to do a string comparison here with finding the object name, and I'm looking for everything that started with fountain, just like we've done before. So I'm looking for all the objects in the scene that start with fountain. And then what's different though now is that I have to make that particular object, once it finds a fountain object, then I have to make the object active. Alright, so I do this with bpy.context.scene.objects.active is equal to this current object dot name right here. So basically I make the object active right here. Make sure the object is active. And then not only that, then you also have to make sure that the fountain associated with that particular object is active. Okay, and I do this with this. I create this variable active fountain, and that is bpy.context.object.particlesystems.active. So I've made the object active, and I've made the specific particle system active, and then I know I'm operating on that particle system associated with that selected object. And then we can go back to settings. So now, using the variable active fountain, I'm going to change the lifetime of the particles to 5.0, and that's no different than in when we were building the scene initially down in here. When the particle system was added, we were using this format that was just using the object that's being added to the scene at the time, and we had set the fountain name, and it's appending .001002 because we never changed that, and we'd set a lifetime, start frame, end frame, and a normal factor. Alright, so we're still using settings.lifetime, but in a different form this time, just by saying the active fountain dot settings is equal to 5.0. Alright, so that's what we're doing, and let me see. Let's make sure we're going to run that routine only for the moment. Modify all fountain particles. Alright, so let's go back to the other window. Zoom in on this a little bit. So notice if I run this, I have some of these are set to run at different heights right now. So this by modifying all of them back to 5.0, let's see what happens. I'll run the script, and it should have found all the objects in the scene. Now if I run here, there it is. I've changed them all to 5. Alright, let's escape that. Let's make them all 50. And I'll run the script again, and I'll press Alt A, and there they have a longer lifetime like this. Okay, so I'm not going to set them back to 5 and run it again. This is really the beauty of having your code in separate files, so you can just do individual things. Now there's one thing, notice I did in here. Let me look back up at the code at the top here. Notice in here I'm also importing the math functions like this, and then in this new routine that I'm going to use, so this was modify all fountain particles, and now instead we're going to do modify specific fountain particles, which is the routine above it. That's this one right here, and it ends right there. Sometimes I do this. Sometimes I'll put this and I'll go end of modify specific fountain particles, like that, and that way I know that's the end of that routine. Maybe I'll give it a space like that. That helps me out also as I'm fast scrolling through code, and sometimes I'll even make that bold face, or I mean in capitals. So in this routine, the one thing different, notice I redefined 2pi in here as well, and I had to bring in the math routines as well because it's separate from this other code. Well, that can be good and bad. The good thing about it is it keeps this routine very distinct from anything else, and that's, I really like that a lot. But sometimes if I know this is only going to be part of this particular program, instead of redefining another variable local to this file and having to import something else like this, sometimes what we'll do is we'll put things in the dictionary, the Python dictionary, which we'll get to here in a lesson or two. And we can put things in lists and dictionaries, and by putting them in a dictionary we're making them essentially accessible throughout between files essentially. But we're not going to do that yet, so that's why I've got it redefined here. But what I'm doing differently in this case for finding specific fountains, down here we cycle through all the data objects and then look for things that start with fountain like this, where in this case I'm setting a couple of variables, get outside theta and get theta, set them to 0, and I'm saying while get outside theta is less than 2pi. So I'm going to have a loop, and within this loop here I build a string, and the string is called fountain plus essentially outside theta plus get theta. So it's going to use whatever. So since we're looping through get outside theta, it starts at 0, and this one's going to stay fixed at 0 for now, and so that's at 0. And then what we do is I take the string and I plug it into here, so as object equals bpy.data.objects.string. After we've built the string, then I get the object based on that string. I also select it to true, make sure it's active, and I print it, or that's make sure it's selected, then I make sure it's active down here. So it's got to be selected and then active, alright? And then this was just like the other routine. I make it active here, then I make the particle system associated with it active, and then I set the lifetime to 150. And then I'm incrementing outside theta by 2pi over 4, or you could change one and make it, you could call pi over 2 if you make something like that, but here is 2pi over 4 in this case. I could have redefined 2pi over 4 up in here. I didn't do it, I just did this on the fly like this. So 2pi over 4 should be 4 instances around the circle. I'm changing the particle system to have a lifetime of 150. Alright, so let's go back here and look at it. So currently here they all are down here with a life of 5. Now since I've changed it to only run modify specific fountain particles, when I run it, it should, let's see what it did. Oh, we actually see it right there. It actually found those 4. There's our x-axis in that direction there. So it would have been at, we were saying get outside theta goes from 0 to 2pi, but so it'd be, here's the 0, here's the first quarter way, second quarter way, and the next quarter way, because we're incrementing it by 2pi over 4. So there's a quarter of the way, quarter of the way, quarter of the way, and then the other one for the inside, or the local theta, was 0, just stayed the same. So there's the 0 radian angles, 0, 0, and 0. So it should have modified those accordingly. And then when we run it, there they go. So now, oh yes, now you can access specific fountain elements and work on them individually and do your own thing. And let's see, so in the next lesson, we're not only going to change the lifetime, but we'll change other things, because now we can really start doing a lot of things. In fact, for a lot of you, I'm sure you're like way ahead of me by now in modifying the fountains or doing whatever, but we'll continue doing it. And there's little details that we'll address. One of the details is this. Notice in here, I put warnings as I go sometimes. So I say, warning, need to test if the object actually exists. Because, well, I know it's going to exist, of course, because I have this specifically, I'm doing these, you know, exact math steps, but sometimes I may get it wrong, and so this really needs to be checked to make sure that this is actually a valid object, because it might not be valid. But so I like to put warnings in there, and this also assumes each object has a particle system. Well, that's a red flag too for me, because I know that if I just forget about that, then down the road that can come back to haunt me. All right, and I don't want it to haunt me, so I always do something in your code to make sure you know you have to fix it. And that really has saved my tail for years and years, and it will for you as well. Okay, so yeah, well, maybe as an exercise, maybe you want to try and modify some of the fountains and make one each blast off at a different rate. Well, you don't have to, of course, because this is an elective class, but I'm just saying, a little exercise doesn't hurt, right? Okay, well, that's it for this lesson, and I'll see you in the next lesson.